Let us start with our topic, which is interference of light. So what do we understand by the word interference of light? Interference is a natural phenomena that happen or occur at every place and at every moment. Yet, we don't see interference pattern everywhere because we are unaware of this particular phenomena, which is interference, right? So, let us describe interference more precisely. So, interference is the phenomena in which two waves superimpose to form the resultant wave of the lower, higher or same amplitude. When two waves are superimposed to gives a resultant wave which can have either lower or higher or same amplitude, then that particular phenomena is known as interference. The most commonly seen interference is optical interference or light interference. So what do we mean by the word optical interference? This is because light waves are generally very random by most of the sources, right? So this means that light waves coming out of a source do not have a constant amplitude, frequency or phase. So it can go under the phenomena of interference. The most common example of interference of light is the soap bubble, which reflects white color when illuminated by a light source, right? We all have seen this particular phenomena when a soap bubble reflects different colors, right? So that is a phenomena which is due to interference. When light falls on the soap bubble, it gives us a different colors, right? So that is interference. Now, interference of light wave can either be a constructive interference or destructive interference. So what do we mean by a constructive interference? Constructive interference takes place when crest of one wave falls on the crest of another wave such that amplitude is maximum, right? When crest of one wave falls over the crest of another wave, in that case amplitude is maximum. That is known as constructive interference. These waves will have same displacement and are in the same phase. Talking about destructive interference, in destructive interference, the crest of one wave falls on the throat of another wave such that the amplitude will become minimum in case of destructive interference, correct? So the displacement and phase of these waves are not in the same alignment or in the same phase. So there are two types of interference. Remember that, constructive and destructive. Constructive will have maximum amplitude, destructive will have minimum amplitude, right? So now let us see more precisely what I have informed you about this examples, right? These are the two examples as you can see here. One of the best example which we can see in our daily life is light reflected by oil film floating on water. Whenever you put some oil over water and when you expose that to light, it will gives you a colored patterns, right? So this pattern or this phenomena of distribution of color is due to interference. One more example is this soap bubble. As we have already discussed that thin film of soap bubble which will reflect a spectrum of beautiful colors, right? All the colors are reflected due to the phenomena of interference. So these are two examples. One is oil floating on water and another is soap bubble. Both will give you a daily life example for interference. Now moving ahead with Next topic, which is diffraction. So what do we mean by the word diffraction? The word diffraction means phenomena that occur when wave encounter to an obstacle or opening, right? Diffraction is a phenomena which occur due to wave encountering any kind of obstacle or opening. It is even defined as interference or bending of wave around the corner of an obstacle or through aperture in the region of geometrical shadow. The diffracting object or aperture effectively become a secondary source of propagation of wave. So what is diffraction? Basically, diffraction is a phenomena that is occurring due to passing through any obstacle or any opening, right? Whenever wave comes in contact with any kind of obstacle or any kind of opening, in that particular case, diffraction occurs. Clear? So here you can see different pictures. These are showing you the phenomena of diffraction, right? The example which is a natural or daily life example of diffraction, you can see here, example of diffraction in nature is diamond rays in the solar eclipse, right? This is it. And this particular example you can see radio which is lying on other side of the wall, and when you start the radio, its frequency will follow this particular pattern, right? This pattern, and the student or any person who is standing here can also hear the wave coming out of that particular part. So this phenomena is happening due to diffraction. So here you can see direction change of waves as they pass through holes, right? So these are the waves which are coming, but when they pass through this particular hole, the direction will be different, right? So this is our diffraction. Now let us classify our diffraction. So diffraction can be categorized broadly into two groups based on method which is adopted to study diffraction effect. First one is Fresnel class of diffraction, and second one is Fraunhofer diffraction, right? So let us discuss what is the basic difference between both the category of diffraction, Fresnel or Fraunhofer. In case of Fresnel diffraction, source and screen are at finite distance from obstacle or aperture, right? Source and screen both are at some finite distance. You can measure that distance. If that is the case, then it is a Fresnel diffraction, right? It is a Fresnel diffraction. In case of Fraunhofer diffraction, both source and screen are at infinite distance from the obstacle. This is the case of sun, you can see, right? Sun and earth are at infinite distance. So we can say we are at Fraunhofer diffraction, right? So in case of Fraunhofer diffraction, you cannot measure the distance or measure the distance between source, screen or your obstacle. Second point is spherical or cylindrical wave front falls on the obstacle aperture, whereas in case of Fraunhofer diffraction, plane waves will form, right? In case of Fresnel diffraction, spherical or cylindrical waves are forming. In case of Fraunhofer diffraction, it is a plane wave which is forming. In case of Fresnel diffraction, no lens are used, whereas in case of Fraunhofer diffraction, converging lenses are used to study Fraunhofer diffraction. Now, waves falling on obstacle or aperture will not be in the same phase when we are talking about Fresnel diffraction. That is, waves which are falling on the obstacle, they will not be in the same phase. Whereas in case of Fraunhofer diffraction, waves falling on the object or aperture will have the same phase. Clear? Now, Fresnel diffraction is general case of diffraction which reduces to Fraunhofer case when source and screen are infinite distance. And whereas Fraunhofer diffraction is a particular case of diffraction with source and screen at infinite distance from the aperture. So make sure that both the cases will be very, very clear to us, right? So there are two cases, Fresnel diffraction and Fraunhofer. In case of Fresnel diffraction, the distance between source and your obstacle is very much defined. You can measure it, but whereas in case of Fraunhofer diffraction, you cannot measure it, right? Now let us see method of producing diffraction. So method of producing diffraction may arise from one part to another, right? So method of producing diffraction arises due to various phenomena. Diffraction is basically a phenomena which is causing due to some reasons because of the way in which wave is propagating, right? The method or the pattern due to which wave is propagating will be responsible for producing diffraction. This is described by Huygens-Fresnel principle and principle of superposition of waves. These two are basically helping us to describe the phenomena of diffraction, Huygens-Fresnel principle and principle of superposition of waves, right? The propagation of wave can be visualized by considering every particle of transmitted medium on a wave front as a point source for a secondary spherical wave, right? So the propagation of wave we can visualize by considering every particle of transmitted medium on a wave front as a point source for a secondary spherical wave. The wave displacement at any subsequent point is sum of secondary wave. This is very important. That is the wave displacement, how much wave has been displaced at any point. If we want to calculate, it is summation of all the secondary waves. When waves are added together, their sum is determined by relative phase as well as amplitude of the individual wave, so that summed amplitude of the wave can have any value between 0 and sum of individual amplitudes, right? So that's why we are saying that the diffraction pattern usually have a series of maxima and minima because there are summation of different waves, right? The quantum approach has some striking similarities to Huygens-Fresnel principle. Based on that principle, as light travels through slit and boundaries, secondary point light sources are created near or along these obstacles, and the resulting diffraction pattern is going to be intensified profile because based on the collective interference of these lights. And lastly, similarly, considering the limited region around the slit and boundaries where the photon are more to originate from quantum formalism and calculating probability of distribution. So this is a process of making of diffraction, or this is a process due to which diffraction is occurring.